Good morning, everyone. I am pleased to greet you. We'll be working on this class in two parts. In the first, we'll be learning the classification of real numbers, and the second part, we will be working on arithmetic operations. I'm going to show you as a PowerPoint slides. To start with the class, I'm going to share my screen. Okay. Thank you for stay here with me. This morning, here we have a slideshow. Okay. Then today we're going to learn about classification of numbers. Okay, specifically with the real number system. Okay. First, we have the, the the first classification is the natural numbers. Okay, are denoted by the capital N, and are knowing like counting numbers. Okay, for example, the number 1, the number 2, 3, 4, 5, and so on. Why we named counting numbers? Because we use them for count when we go into the mall or to buy something, some stuff or something, something. Um, for example, when going to the market and we going to buy fruits, I'm going to take, if I going to take apples, I going to take one apple or two apples or three or four or five, but I don't take zero apples or a half, one apple and half, or quarter of half. Okay, we got we take um, just numbers like this. Okay, 1, 2, 3, 4, 5, and so on. All the positives. Okay, this is the first group. Okay, the counting number does not include zero. Okay, the natural numbers does not include zero and not include the negatives. Okay, natural numbers, capital N, 1, 2, 3, 4, 5, and so on. Does not include zero and does not include the negatives. Okay, remember that is very important. Another group um, of classification that we're going to learn today is the whole numbers. The whole numbers include the natural number and zero, okay? And we can denote it, the whole numbers, with the capital N, the capital W. um, like you can see in your screen the capital W, whole numbers. And our friend are saying in the cloudy talk, any natural number is also considered a whole number, but not necessarily it other way around. Okay, the natural number are included inside of whole numbers, but the whole numbers, like the zero, is not included in the natural numbers. Okay, continue. In another group of classification of real numbers are the integers. Integers. Okay, integers. The integers can often be denoted using this symbol. Okay, the symbol capital Z. The capital Z denote integers. What are the integers? The integers include include the natural numbers, include the whole numbers. Okay, natural numbers. Remember that we named, or we know, like counting numbers. Natural number is the same that counting numbers. Remember that. Include the whole number, the capital W, whole numbers. Okay, is the zero plus natural numbers. And the integers, and the integers includes the negatives. Okay, zero, the natural numbers, positives, and the opposites. Okay, the negative numbers. And our friend and are telling us also include all the negatives of them as well, such as, and we can see in the picture, in the slide. Okay, integers. But again, the integers not include, what not include, not include the decimal numbers, or the numbers that contain decimal. Does not include the negative numbers, not include the fractional numbers, fractional negative, fractional positives, negatives, number decimal and negative, and decimal positives are not included in the years. Okay, in the years. Continue. Another group that we need to know are the rational numbers. Okay, and our friend Einstein and tell us can be denoted using this symbol. What symbol? The capital Q. The capital Q that we have in under rational numbers. Capital Q denote the rational numbers. Rational numbers includes the natural numbers or counting numbers um, includes the whole numbers. The whole numbers are the zero plus the natural numbers. Um, Also includes the integers. Integers are the negatives plus zero plus natural numbers, okay? And the rational numbers includes all the natural, whole, and integers plus the numbers that contain decimals and numbers that contain fractions, okay? Or fractionals number. We can watch in the slide natural numbers 1, 2, 3, 4, and so on. 0, the negatives, -1, -2, -3, -4, and so on. We can see decimal numbers like 3.3 or decimal numbers in negative like minus or negative 2.6. And we can see that the rational numbers include two, the fractional numbers and like the fractional 1 divided by 2 and the fractionals like negative fractionals like -9 divided by 2, okay? Continue. And this slide we can see at the right we can we can see the rational numbers, okay? It's another group that is not included in the rational numbers. Now here in this universe of real numbers we can two big groups: the rational numbers that are denoted by capital Q and the irrational numbers that are denoted by the capital P, okay? Irrational numbers, capital P. And the column of the left, you can see all the classification: natural numbers, whole numbers in color, in green color, the integers, capital Z, in the purple color, rational numbers that are denoted by capital Q in the color blue color, and the other classification, okay? Other classification, irrational numbers. And if we read the rectangle green that we have in above of the circle orange, the irrational numbers, capital P, can't be represented as a fraction, okay? Why we cannot represent the rational numbers like a fraction, as a fraction? Because our numbers biggest numbers, okay, or larger numbers. And like we have here one example, the number P, okay? Number P is if an infinite number, okay? Not ending number, 3.0 0.1415, and the numbers continue, okay? And non-ending number. Let's to see the um, characteristics of rational numbers, okay? The irrational numbers um, are numbers that cannot be expressed as a fraction. Example, non-ending, like the p, like the symbol or the constant e, that is the constant e are logarithmic constant. Another characteristic, non-repeating decimal, okay? Non-repeating decimal. If I tell you 3.33333 and so on, are a rational number. It's not irrational, okay? Why? Because the decimals are repeating 33333, but instead of that, the irrational numbers, um, the characteristic are that non-repeating decimals, okay? Like the p, like the um, e constant, logarithmic constant e is non-repeating decimals, okay? The p non-repeating decimal are non-ending number, okay? The square root 2 are cannot be represented like a fraction, okay? And these are all the universe of real numbers, okay? And this is all the universe of real numbers. We have two big groups, the rational numbers at the right in orange color, and the rational numbers, capital Q, that include the integers, the whole numbers, and the natural numbers, okay? We have two big groups, rational and irrational numbers. But here don't ending, okay? Here not ending. We have another classification of numbers, okay? We have complex number, okay? We have a complex number. Complex number are not included in the real numbers, but the real numbers are um, formed with a real number and imaginary number, okay? The complex number has um, two parts, the real part and the imaginary part, okay? Here we have some examples. Complex numbers, 3 minus 4 times e, okay? The number 3 is the real part minus the imaginary part, 4 that multiply the imaginary, okay? E. And we have all the classification of numbers, okay? Thank you for your attention. Is this with this end the first part of um, the classification of real numbers, okay? Um, I'm going to we need to go to do review of the classification of numbers. Okay, um, if I say um, um, I can ask you some number and you need to give me the classification. If I say the -7, I can ask you if the -7 are included in the whole numbers. The -7 are included in the whole numbers, and you need to answer. Okay. In this part, I can make feedback with the students. Okay, but in this class, I'm not with the student. I am alone um, recording the class. Okay, but in this part, I can make questions and a feedback of doubts that the student has. Okay, let's continue. I'm going um, to start with the second part of the class. Okay, I'm going to close these slides. The slides are in the classroom. I share with the students. These slides are shared in the classroom. Okay, this slide or this presentation in PowerPoint, I share with the students. Okay, now I'm going to pass at the second part of the class continue with the topic of the class. Okay, classification, the first part, and operations with integers. Operation with integers, and we can to see the number line um, if we need it. Okay, um, let's continue with operations with integers, but before that I start with this topic, I want to show you algebra. These slides. Okay, remember that we are in the BIS university. Okay, and we need improve our language. Then we need see this before that we see the other topic. Okay, arithmetic in English. We need to know how can I say the symbols or the operations in maths. Okay, and we need um, improve our language or listening or speaking. how to read the arithmetic symbols, okay? And the operation of addition are um, addition, okay? And subtraction and multiplication, okay? The operation of division, we denoted by this symbol. The addition are denoted by this symbol. That plus the subtraction are denoted by this symbol. The minus and the multiplication are denoted by this symbol. Okay, times or statistic. Division are denoted by the slash or the symbol of divided by basic symbols. Okay, we have here the symbol equal sign. Equal sign. How to read the arithmetic symbols and plus. Okay, minus, times, divided by. Here we have another symbols like the addition. For we going to know the symbols that we are going to learning in the class. Maybe in this class not see all these symbols, but you going to you will and see in another class on another subject, okay? Maybe in calculus or physics, you will see these symbols, okay? Like not equals when we are going to we will see the inequations or equals, or maybe when we um, see the operation with symbols of aggregation, okay, parentheses, brackets, curly brackets, okay. How to read the arithmetic operation? If you can repeat after me, when we see the addition o la suma o el signo de más, lo vamos a leer. We're going to learn, read like addition and plus. If you can repeat after me, addition, plus, and we are going. We if we read this operation, we need like the the paragraph or the sentence is in red color. 5 plus 2 equals 7, or maybe equals 2, okay? We can use both um, forms. 5 plus 2 equals 7, or 5 plus 2 equals to 7, okay? Is the correct form to say or to read the operation, that addition that we have here. And in the case of subtraction, la resta o el signo menos, we need to read subtraction is the operation and the minus is the symbol, okay? Subtraction is the operation and minus if the symbol of the subtraction, okay? And you can repeat the sentence in red color is the correct form to read an operation. of subtraction in this case. And if you can repeat after me, 7 minus 2 equals 5. Okay, is the correct form to read this kind or this sort of operations. Okay, in your home you can repeat 7 minus 2 equals 5. Okay, and multiplication, when we have an multiplication o multiplicación, que es la operación, y por, que es el símbolo. Multiplication is the operation and the symbol are denoted or named times. Okay, times is that we know like por in español. Okay, and then we can read this operation um, that we can see in the color, the sentences in the color, the red color. Okay, 5 times 2 is a multiplication. 5 times 2 equals 10. 5 times 2 equals 10. 5 times 2 equals 10. If you can repeat after me, 5 times 2 equals 10. Okay, repeat in your home. Here, in these cases, um, I tried to listen the speaking of the learners. Okay, and many times I asked to the students or make the participate at the students, but I repeat, I recording alone. Okay, but in these cases, I make questions. I ask for some for I ask that he or she read some paragraph or some sentence in this when the class start. I take list or take the names that the students are in the class, and I take notes that who are um, in the class. Okay, and then in the class I'm going to ask them um, with the names that I have in the list. Okay, like parentheses. Okay, division and the operation of division. um, we have this operation, 10 divided by 2 equals 5. Okay, if you can repeat it after me, 10 divided by 2, 10 divided by 2 equals 5. Okay, another symbols that we are going to seeing percentage that we have here is the symbols that we can see in the stores of clothes when we're going to maybe buy some clothes. This this the price is 25% of minus 25%. Okay, we can read this number like this in the red color, 25%. 25%. Okay, and we when we have this this kind of number that includes the decimal or the point decimal point, we can read like this: 1.2. Okay, 1.2, 1.2. Repeat after me: 1.2. Okay. Here we have another kind of symbols, so another kind of operations when we will see in equations or inequality. We will use this kind of symbols: greater than, or then, or less than. Okay, when you saw the last uh, period of class, maybe you see this kind of words. Okay, greater than or less than, like superlatives. Okay, is a topic that you maybe you are learned before. Okay, and we can read these operations inequality when we use greater than, and in the color yellow: 5 greater than 4. Okay, repeat after me. This is an operation of inequality, and the color yellow we can read like this: 5 greater than 4. 5 greater than 4. Okay. Another inequality with this symbol less than, and if we can read this operation: 4 less than 5. 4 less than 5. Okay, are superlatives. Another symbols, okay, it's one point. Don't forget, how do you say? Okay, it's time that you can practice. Okay, how we can read these operations and that we have here. um, Multiplications, we have 3 multiplication. How you can, or how do you say the first operations, the first operation? How do you say? You can say in your home, or you can turn on your mic and share with all your partners. Okay, how do you say that the second operation, and how do you say the third operation? Excellent, excellent. Okay, and in the first operation, like feedback, the first operation I can read like this: 6 times 3 equals 18. All right, 6 times 3 equals 18. Don't forget the teen at the end. 18, 18, 18. That we don't confuse with 80. Okay, 80 and 18. Okay, in the second, how do you say? 12 times 2 equals 24. 12 times 2 equals 24. Okay, and the third operation we can read like this: 4 times 4 equals 16. 16. Don't forget, make the emphasis at the last of the number or the word. 16. Okay, 16. How do you say these operations? How do you say these operations? These are additions. Okay, we are using this symbol in the blue color. It's plus. Plus. Okay, plus, not plus. Not plus. Okay, not plus. Don't forget plus. The letter U is make a sound like a. Plus, like Hulk, the green monster. Okay, Hulk. Eh, yes, plus. And how do you say the first? How do you say the first operation? You can repeat in your home. You can repeat in your home. How do you say these operations are additions? We have here three additions. Okay, you can practice in your home. You can practice with the with your your partners. You can turn on your mic and you can participate in the class. Okay, how do you say the first operation? I can say 9 plus 8 equals 17. 9 plus 8 equals 17. Okay, 17. And the second operation, how do you say? How do you say the second operation? I can you can practice. Okay, 11 plus 4 equals 15. 15. Sorry, 15. 15. 15. And the last, but not less, 8 plus 12 equals 20. 8 plus 12 equals 20. Okay, very good. Let's continue. Now, here we have um, this operation. Okay, which kind of operation are? Right, okay. We have a subtractions. That's right. We are using the symbol minus. Okay, minus. And how do you say? How do you say the first operation? How do you say the first operation? How do you say the first operation? 19 minus 8 equals 11. 19 minus 8 equals 11. Okay, you can repeat after me in your home. 19 minus 8 equals 11. Okay, very good. In the second operation, how do you say? How do you say the second operation? 27. 27 minus 13 equals 14. Okay, okay. And the third operation we can read like this: 15 minus 3 equals 12. Okay, these are subtractions. Subtraction is the operation, and the symbol that denoted the subtraction are named or denoted by this symbol and named minus. Okay, all right. And we have this another operation. Okay, we have this another operation. How do you say this operation? We have three. The symbol, we can say divided by. Okay, divided by are the symbol of the divisions. How do you say this operation? You can practice in your home. Okay, you can practice in your home. 24 divided by, don't forget, divided by is the symbol, and the operation is the division. Okay, the operation is a division, and the symbol is divided by. 24 divided by a equals 3. Repeat after me: 24 divided by a equals 3. Excellent, excellent, very good. The number 2, how do you say the number 2? 10 divided by 2 equals 5. Excellent. Repeat after me: 10 divided by 2 equals 5. Okay, excellent. We continue with the number 3, and the last but not the least. Um, how do you say the number 3? 21 divided by 3 equals 7. Repeat after me: 21 divided by 3 equals 7. That's right. Very good. Nice. And that's are all with this arithmetic in English. Okay. Don't forget that we are university, BC University. Okay. We are bilingual. We are bilingual, bilingual. Sorry, bilingual. We need to improve day by day. Okay. Day by day, we need to improve our language, all of us. And now, um, if you have some question or some doubt about this how to say or how to read this operation, some doubt, this slide you you got in the classroom. I shared with you in the classroom this slide, this PowerPoint presentation. You have, or you can search in the classroom. I attach you in the forum. Okay, some questions. Okay, very good. Continue with the class. Now we pass to the second part of the class. Okay, we need to learn about operation with integers. Okay, objective: add, subtract, multiply, divide positive and negative numbers. Okay, this is um, um, a review. Okay, this review. We need um, remember or the use with the negative numbers. Okay, pre-algebra in integers. Okay, objective: add, subtract, multiply, and divide positive and negative numbers. Okay, this is the second part of the class. You can read in this part of the class. I make participate the students reading, but not just that reading. Okay, we use color code to study vocabulary, and we search words that they don't know the meaning, or they don't know the correct pronunciation, and we make a list here below at the paragraph, and make a list, maybe whole, maybe a review. Okay, and we um, practice our vocabulary. We practice the reading, we practice our listening, and the class belong to more interactive class. Okay, it's not monologue, is interaction of all the students. We write here the questions. I ask at the student which word does not know, uh, and we make a list. We solve their doubts. Okay, okay. But I'm make all along. Okay, in this occasion, but in a real class, I ask to read a paragraph, to to focus in the pronunciation. We focus in the grammar, in the correct pronunciation, and in improve our vocabulary, searching or solving the doubts with the words that they don't know. Okay, but in this occasion, I'm talking more. Okay, sorry. Okay, well, uh, I'm going to read the paragraph for all of you. The ability, the ability to work comfortably with negative numbers is essential. Is essential to success in algebra. Okay, the ability to work comfortably with negative numbers is essential to success in algebra. This is important. Okay, this is important. Um, to succeed in algebra. Okay, for this reason, we will do a quick review of adding, subtracting, subtracting. Don't forget subtracting. Okay, adding, adding, adding. Don't forget the ability to work. You can repeat after me. The ability to work comfortably with negative numbers is essential to success in algebra, okay? For this reason, we will do a quick review of adding, subtracting, multiplying, and dividing of integers, okay? Do you remember the classification of numbers? Do you remember which are the integers? Huh? If you forget it, we have here, don't worry, okay? We have here the definition of integers. I'm going to make in blue. Integers are all the positive whole numbers, zero, and their opposites, the negatives, okay? That's are the integers. This is only a review, okay? As this is intended, okay, here we can make a parenthesis with this word, okay, because we um, have here ending ed, okay. We can remember the use of the rule when we need read the ending ed, intended, okay, intended. When we have an d or t, we need to read the ending ed, okay. Don't forget that. That's important, okay. That's important to improve our pronunciation. It's a rule, uh, important rule, okay. As this is intended to be a review of integers, the descriptions and examples will not be as detailed as a normal list, okay? This is only a review. I know that you know how to do this operation, okay? This is only a review uh, because it's essential to success in algebra, okay? This is the basics, okay? The, it's essential. Okay, continue. If you can um, repeat or searching the words that you don't know, you can write in the chat or make or turn on your mic and you can answer. You can make me a question and ask me for the meaning of the words. Okay. Um, Continue when I'm going to read, but you can um, repeat after me, okay? To you improve our pronunciation, okay? Remember that the pronunciation maybe is not so important. The important is that you can um, uh, share your opinion, you can share your ideas, okay, that the other persons or the other people um, understand that you can say, okay. All have, or all the people has the different accents, de acuerdo. Don't worry by the pronunciation, but we need improve our pronunciation, okay. Repeat after me. When adding in years, we have two cases to consider. Okay? We have two cases to consider. This is important. The first, I'm going to mark the third case, the first case, okay? We have two cases. The first, we have two cases. This is important. Don't forget it. The first case is if the sign match, okay? I'm going to put in bold if the sign match. Don't forget it. The first case or the first case is if the sign match, okay? But positive or but negative, okay? This is the condition. Um, but positive or but negative. I'm going to put in another color. I don't know, don't mark it. Okay, but positive or but negative. If the sign match, we will add, if the sign match, we will add the numbers together and keep the sign. This is illustrated, remember the ending ed, illustrated in the following examples, okay? And example number one, we have here an operation, okay? Which kind of operation are? Is an addition. Very good. It's an addition. It's an addition. It's not a subtraction. It's not a multiplication, okay? Is an addition. Don't confuse, okay, with a multiplication. That's important. That's important. This is the the objective that we are making a quick review of adding, subtracting, multiplying, and dividing. Okay, we use the negative numbers and the parentheses. Okay, and example number one, we have an addition. Okay, if you can watch um, this operation, in this operation we have two numbers. Okay, we are adding two numbers, negative 5 and negative 3. And if you can observe, they have the same sign. What we're gonna do? Add both numbers. Why? We just follow this rule, okay? If the sign match, we will add the numbers together and keep the sign. Is all that we need to do, okay? This is very important that you remember this, okay? If the sign match, we will add the numbers together and keep the sign. We have here a addition, okay? We have here an addition. We have here an addition of numbers with the same sign. What we're gonna do, add both numbers and keep the sign. In this case, the sign is negative. Our solution negative 8, negative 8, okay? Negative 8. Same sign, add the numbers, keep the sign. Okay, example number 2. In this example number 2, we have another subtraction. Okay, and the solution is the same. We have the first case, same sign, add 7 plus 5 is 12, and keep the negative, because both numbers has the same sign. Okay, just add both numbers and keep the sign. Here we have another case. Okay, the other case number, or the case number 2, if the sign don't match. Okay, this is important. This is important. What we gonna do if the sign don't match? What we gonna do? Maybe one positive and one negative number. Okay, one positive and the other is negative. Okay, we will subtract the numbers as if they were all positive. Okay, remember that, as if they were all positive. This is important. And then you design from the larger number. This is the rule. And then don't forget this part, because it's essential to the correct resolution of the operation. Okay, we will subtract the numbers, the both numbers, and then use the sign from the larger number. Okay, this means if the larger number is positive, the answer is positive. If the larger number is negative, the answer is negative. Okay, this is shown in the following examples. Is this the case number 2? Example number 3, the case number 2, or the second case. Okay, if the sign don't match. The first case, um, the signs match. Okay, this is the first case. The sign match. The second case, the sign don't match. Okay, don't match. One positive and one negative. What we need to do? We will subtract the numbers and then use the sign of the larger from the larger number. Okay, let's to watch the example number 3. We have here an addition. Okay, we have an addition, but the difference here is that we have two numbers, but um, they have the different sign, one negative and one positive. Okay, this is the second case. What we're gonna do? um, Different signs we can read here. Different signs subtract the bigger number, 7 in this case. 7, we going to subtract at the bigger number the the little number. Okay, -2 are 5. Okay, but we conserve, or we keep the sign of the bigger number or the larger number. Here we have in the rule, then use the sign from the larger number, okay? Different sign, subtract 7 minus 2, use sign from bigger number. Is the negative sign, okay? 7 minus 2, 5, and use the sign from bigger number. That's the rule, okay? That's the rule. Our solution minus 5, negative 5, okay? This is the rule. If we have an addition of numbers with different signs, subtract the numbers. The big number minus the small number or the little number, um, and keep the sign of the larger number, okay? Example number 4, we have here another subtraction. We have two numbers with different signs, minus and one, pardon, sorry, one negative and one positive. We subtract 6 minus 4, and using the sign, in this case is positive, the bigger number is the 6. We use for the bigger number, the sign of from the bigger number, positive. In this case, 2 is our solution. 6 minus 4 is 2. And keep the sign of the larger number, okay? This is the rule. Example number 4. Here we have parentheses, okay? We have here parentheses. What happened? What happened with this operation? We have a parenthesis, and what we going to do in this case? In this case, we have 4 plus and then a number between parentheses, okay, and negative 3. We just um, following the rule, okay? What say the rule? Different sign, we just subtract the bigger number minus the little number. 5 is the bigger number in this case, and the little number is 3, okay? I have the subtract. I can eliminate the parentheses, okay? We use the sign from bigger number. ¿De acuerdo? Okay, the positive is our solution. 4 minus 3 equals 1. And keep the sign of bigger number. In this case, the 4 is the bigger number. It's the same for the example number 6, okay? It's the same um, um, problem. Now, we pass with another operation, okay? We saw additions. Now, we need to review what happened with the subtractions. What happened with the subtraction? Subtraction of negatives, okay? Subtraction of negatives. That's important, okay? We will change, you can repeat after me. For subtraction of negatives, we will change the problem to an addition problem, which we can then solve using the above methods. Okay, we will we we need to change the problem. Okay, the way we change a subtraction to an addition is to add the opposite. Okay, this is important. The way we change subtraction to an addition is to add the opposite number. Is to add the opposite of the number after the subtraction sign. Okay, often this method is referred to as add the opposite. Okay, because we need add the opposite. This is illustrated um, in the following examples. Okay, example number 7, we have here an subtraction. What we gonna do? We need to transform or change the operation to an addition. Okay, different signs. Subtract 8 minus 3. You sign bigger number, positive or solution. We just change the operation in addition. Okay, 8 minus 3, 8 plus the negative, because here we have a sign. Okay, this is the sign of the operation, but the number has or the own sign. In this case is 8 minus positive 3. Okay, if we have positive 3, when we change this operation 8 minus instead of 8 plus negative 3, the sign of the 3 here is positive. We add the opposite, is minus 3. Okay, and we have here addition with the numbers that their sign don't match. Different signs, subtract the bigger number, add the little number, and keep the sign of the bigger number. Okay, it's the same um, solution. Example number 8. Here we have an subtraction. We can change this operation in an addition. Minus 4 plus minus 6. Same sign, is an addition with numbers that they has the same sign. I just add both numbers and keep the sign. Okay, that's the rule. And the same for these operations. What happened with the multiplication? What happened with the multiplication and division of integers? What happened? Multiplication and division of integers. Both work in a very similar pattern. Okay, it's similar but not is the same. Be careful with this. Okay, the short description of the process is we multiply and divide like normal. If the sign match, the answer is positive. Okay, this is important. If the sign match, the answer is positive. The answer is positive. Okay, if the sign match, the answer is positive. If the sign don't match, I'm going to put with another color. If the sign don't match the answer, then the answer is negative. Okay, this is show of the following examples. The pattern is similar, okay, but the process of solution is different. Okay, don't confuse an subtraction or addition with a multiplication. Okay, that is issue very common. Okay, example 11. 4 times negative 6. Okay, don't confuse with subtraction. Here we have two numbers between parentheses. Okay, that's mean that is an multiplication of two numbers with different sign. If we have different sign or the sign don't match in this case that we can read here, if the sign don't match like this case, 4 times minus 4 times negative 6, the signs do not match. Okay, the answer is negative. The answer is negative. um, example number 12. Here we have division. Okay, the first that I observe, or that the first that I see, is this the sign of both number is the same sign. If the sign match, the answer is positive. Okay, and 9 times 4 equals 36. Okay, or um, 36 negative divided by 9 negative equals to 4. Okay, when we um, have numbers with the same sign, the solution will be positive. If we have a multiplication or division with different signs, the solution is negative. Okay, remember that. Here we have example number 13. Negative 2 times negative 6. If we can see, or we can observe, the sign match, the answer is positive. Okay, negative 2 times negative 6 equals 12. Positive. Positive is the solution, but we not include the sign positive because it's not necessary. Okay, just when the answer is negative, include, we can or we need include the symbol, or the, yes, the symbol, the sign of the number when it's negative. Example number 14. We have division is the same operation. Okay, different sign, the sign don't match, answer is negative. Okay, and 15 divided by my negative 3 equals negative 5. Okay, this is a note. Okay, this is a very important note. Okay, very important note. We need to read this paragraph carefully. Okay, because sometimes or many times we can confuse, we can make an operation in a grown way because we can confuse the operations, okay? When we use negative numbers. When we use negative numbers, um, and parentheses, okay? We need to be very um, careful at the moment to solve this kind of operation. We need to read, okay? Let's to read this paragraph and repeat after me. And if you don't remember that, if you don't know the meaning of some word, you can answer in the chat, or you can open your mic and make your give us your opinion, okay? A few things to be careful of when working with integers, okay? First, be sure not to confuse a problem like -3 minus 8 with, I'm going to mark, okay, to differentiate these operations. I repeat, first, be sure not to confuse a problem with -3 minus 8 with this other problem, or this other operation. -3 times -4, okay? And we have here the acceleration. The second problem is a multiplication problem because there is nothing between, watch this, between the 3 and the parentheses, okay? Are nothing, oh, is nothing between 3 and the parentheses, okay? This is a multiplication. -3 times -8. Continue. If there is no operation written in between the parts, then we assume that means we are multiplying, okay? We are multiplying. The first operation, in this case, -3 minus 8 in an orange color, okay? Here we have the -3 minus 8 problem is subtraction. Is subtraction. Please focus here, okay? The -3 minus 8 problem is subtraction because the subtraction separates the 3 form that come after it, okay? Another item to watch out for is to be careful to not mix up the pattern for adding and subtracting integers with the pattern with multiplying and dividing integers, okay? They can look very similar. They can look very similar, but not the same, okay? For example, if the sign match on addition, we keep the negative. And we have here an example, okay? This is an addition. This is an addition. This is an addition. They can look very similar, okay? For example, is the sign match on addition? If the sign match on addition, we keep the negative. In this case, okay, it's a subtraction. Sorry, it's an addition, okay? It's an addition. It's an addition. It is the first case. We have here two numbers and the signs match. We just add but and keep the sign, okay? But if the sign match on multiplication, the answer is positive, okay? And we have here another example. Negative 3 times negative 3 times negative 7 equals 21. Please be careful with this, okay? These two cases is very common that we confuse it. If you have not any symbol or a negative symbol before the parentheses, before parentheses, you can eliminate the parentheses, okay? But if you have another operation one or another, if you have a sign minus or another number that are multiplying, we have um, maybe a multiplication, or maybe the signs before the parentheses are modifying your number, okay? Be careful with this. Multiplying and dividing integers, we have here picture just for review that we saw in this case. In this class, multiplying and dividing integers on the same sign, it's okay, positive. If this different sign, negative, okay. Different signs, negative, same sign, positive. In dividing and multiplying, okay. Multiplying and dividing integers. Don't confuse with subtracting or addition, okay. And here we have some um, expressions, okay, to practice that we are learning today. Practice in years, okay. And I'm going to give you in 15 minutes or 10 minutes, okay, 10 minutes to solve the operation at the left column, okay? This operation, just 15 operation. You can uh, uh, make in your notebook, or you can do it in a Word document, Word, or in another digital uh, tool. Okay, I'm going to give you um, 10 minutes to you for you can solve this operation. The left column is that you is for you practice. Okay, you can start. If you have some um, doubt, you can write in the chat or open your mic if you have a question about some problem. We have here some expressions: 1, 3, 5, 7, 9, 11, 13, 15, 17, 18, 21, 23, 25, 27, 29 are the expression that you will calculate. Okay, you will solve. You will need to solve. The time is running. Okay, I'm taking the time, 10 minutes, just 10 minutes um, to solve this operation, and you can practice. And then we um, are we will solve in the class here. We are will we will solve this operation after the 10 minutes. Okay, and you can compare your results in your notebook or where you are taking the notes. Okay, the time is running. I will attach this document in the classroom, and you can review when you have the change or the time. You can review these notes. Okay, if you have some question, you make can make your question. We can solve your doubt. Please, um, we learned today the classification of real numbers, we saw two groups, the rational and the irrational numbers. We saw examples. We learned how to read the arithmetic operations, and now we are practicing the arithmetic operations, okay, of subtraction, addition, multiplication, and division, okay? When the time is over, we will um, solve some of these operations for you can compare your results, and if you have some doubt about some operation, we can uh, solve your doubt, okay? 4 minutes, 4 minutes, okay? Just the left column, okay? Just this, the left column. Remember, or don't forget, do not confuse subtractions with multiplications, okay? Be careful with the signs before the parentheses. 2 minutes, 2 minutes, and we will solve some exercises or operations, okay? In these cases, you can use preferably the method that we sorry, the method that we uh, saw in this class, okay? Preferably, but you can do it maybe in another way. It's okay. Okay, the time is over. Let's to solve these operations. Okay, I'm going to solve in this page. In this page, I share the paint. Okay, here in paint to I can write here. Okay, in the first operation we have an addition. Okay, the rule that we learned in this occasion said in this case that I need change this subtraction in an addition. Okay, 1 plus minus 3. Okay, now we have um, here an addition, but if I can observe here, we have an addition, but the numbers has the different sign. Okay, then 3 minus 1 equals 2, and keep the sign of the bigger number. Remember that? Okay, that's the rule that we learned today. Okay, here we have the rule, and here when adding, if the sign match, we will add the number together. No, the second case, if sign don't match. Okay, like the case number or the operation number 1, if the sign don't match, one positive and one negative, like this, we will subtract the numbers and then use the sign for larger number. Okay, we have the rule here. Okay, let's continue solving these operations. The number, um, maybe the number, I don't know, the number 15. Number 15. And we have here an addition. Okay, we have here an addition, but we have here an addition of numbers with the signs don't match. Okay, we can eliminate the parentheses. Okay, minus 5 or negative 5 plus 3. We have here an addition, but the signs don't match. If the sign don't match, um, if the sign don't match, subtract the numbers. Okay, the bigger number minus the little number, and keep the sign of the bigger number. Okay, that's equals to 5 is the bigger number minus the little number 3 equals 5 minus 3 equals 2, and keep the sign of the bigger number. The bigger number in our addition mm, in our addition is negative. Okay, negative. I put in the color green color. Okay, here we have minus 5 or negative 5 plus 3 equals 2, like the rules say or tell us. If the sign don't match, one positive and one negative, we will subtract the numbers if they were all positive, and then use the sign from bigger number. Okay, that's the number 15. Okay, therefore 5 minus 3 equals 2 minus the negative 2. That's the answer. And the last one to finish with this topic today, minus 7. We can eliminate the parentheses, okay? Because we have not any number or any other symbol before the parentheses, okay? Minus 7 plus 7. And it's the same, it's easy peasy. 0, okay? 0. And that is all for today, guys. I I wanna give you thank you for being here with me today. Okay, and the homework is the other operation that you have in this document that we work in it today. At the last page, you have multiplication and divisions. Okay, you need to solve all of them and submit your work in the classroom. Okay, that is all for the class. Thank you very much for your attendance. See you in the next class. Goodbye.